Alright, y'all, so in this video I'm going to talk about a few of the basics of arithmetic sequences. So remember that arithmetic sequences are whenever we have a common difference or we're adding or subtracting by the same number for each term. So it says right here to determine the common difference and find the next four terms of the sequence that goes 12, 10, 8, and so on and so on. So if we're determining the common difference, we know that this has a pattern that's adding or subtracting, and I see that it's decreasing, so that's as if we were adding -2 every time. So our common difference, which we call D, would be -2. And if they want to find the next four terms of the sequence, we could just keep subtracting -2, and we would end up with, after 8, 6, minus 2 would be 4, minus 2 would be 2, minus 2 would be 0, and that would continue, but it asks for just the next four terms, so I'm good to go. Next up, it says write a recursive formula to represent the sequence. So we've learned two different ways to write an arithmetic sequence, either recursively or explicitly. If I define it recursively, I have to give you the first term, your starting point. So in this case, A1 is 12. And then we get to say that every term after that we're adding -2 or subtracting 2. So the way that we would write that is any term an, I would take the term before. So if I'm on an, the term before would be an minus 1, and I'm going to be subtracting 2 from that, or adding -2. You could write it as subtracting 2 or adding -2. So this would be my recursive definition. Then it asks for our explicit definition. So we have a formula for that we can use. It says an is always equal to a1 plus d times n minus 1. And the reason, remember, is because we start with our first term and then we're adding our common difference over and over and over, and we're adding it a certain number of times. So when we're on the third term, we're adding it twice. So we're always going to multiply times 1 less than whatever term number we're on. So in this case, we'd say an equals our first term, 12, plus our common difference, which would be plus a -2 or minus 2, times n minus 1. And I can simplify by distributing the -2, -2n plus 2, and then combining like terms. 12 and 2 would be 14. So I have an equals 14 minus 2n. So I can use this formula to find any term n down the line. And this is probably going to be more helpful if I ask for like the 100th term, so that I don't have to go one by one by one. I could just plug in 100 and figure out what that 100th term would be. So that brings us to the last question. It says, what is the 25th term in this sequence? Now I could continue like I did here to keep subtracting 2 all the way until I get to the 25th number in the sequence. But now that I have my explicit formula, the nice thing is I can find a 25 by plugging in 25 for n. So I can say 14 minus 2 times 25. 2 times 25 would give me minus 50, and 14 minus 50 would be -36. So we will end up with -36 as the 25th term.